Module 11. All right, so we've got two graphs. One looks like this, and the other one looks like this. And we want the area, that was like a really, really bad sketch, but we want the area between the two curves. So we are going to take the top equation, which is this one, minus the bottom equation, which is this one, and we're going to find the area between the two curves. So the first thing I need to know is what are my limits of integration. I need to know what this point is and what this point is, because that's where the two equations meet. So I've got x minus 2 squared, and that's going to equal 2 times x minus 3 squared minus 2. So I'm going to FOIL this out, which is x squared minus 2x minus 2x plus 4. Don't really need a parenthesis there. Equals, I'm going to FOIL this out. So I get 2x squared minus 3x minus 3x minus 2. I'm sorry. I forgot a whole chunk right there. Plus 9 minus 2. Combine like terms. I get x squared minus 4x plus 4 equals, I'm going to distribute this 2. So 2x squared minus 6x times 2 is minus 12x. 2 times 9 is 18, 12x. I'm just making a grand spectacle of things. Minus 2. Okay, combine like terms again. Okay, so we're on our way to figure out what these 2 points are in terms of x. So, since this is positive and bigger, I'm going to move everything over to the right side. So I'm going to subtract x squared. I'm going to add 4x. And I'm going to subtract 4. So that gives me x squared. Negative 12 and 4 is negative 8x. 16 minus 4 is 12. Equals 0. And when I factor that, two numbers that multiply to 12 that add up to negative 8 are going to be negative 2 and negative 6. So if my factor is x minus 2, my solution is 2. If my factor is x minus 6, my solution is 6. So I now know my limits of integration. So we're going to flip this over and write the equations again. We have y equals x minus 2 squared. And y equals 2 times x minus 3 squared plus 2. And now I know that my lower and upper limits of integration are 2 and 6. And I've got red minus blue. So the red equation, which you'll see on WebWork, and the blue equation, so I've got red minus blue dx. So we're going to go from 2 to 6 of the red equation, which is x minus 2 squared, minus the blue equation, which is 2 times x minus 3 squared plus 2 dx. And I just expanded these a while ago, so we're going to rip through and do it again. I'm going to go from 2 to 6 of x squared minus 4x plus 4 minus, this was a 2x squared minus 6x which would be minus 12x plus 18 plus 2. Or was that a minus 2? That was a minus 2. I was going to say that is not working out the way it was supposed to. All right, minus 2. Okay, minus 2 dx. Okay, so combine like terms again. And we're going to go from 2 to 6. X squared minus 2x squared is a negative x squared. 4x minus a negative 12x is going to be negative 4x plus 12x, which is 8x. And then 4 minus, this is a 16. So 4 minus 16 is going to be negative 12 dx. And now it's ready to integrate. So negative x squared, we get a negative x to the third over 3. 8x becomes 8x squared over 2 minus 12x. And we're going to take that from 2 to 6. So always evaluate from top to bottom. So I've got a negative 6 to the third over 3 plus 4. 6 squared minus 12 times 6 minus, evaluate it, 2 oh no. Okay, and when we slap all this in the calculator, we get hold please. Plus minus and what do we get? We get 32 thirds. So we have 32 thirds. I'm going to do another couple of examples of this one, or not this one. All right. We have a graph that looks like this. And then it looks like this. And this is not drawn to scale. So we have that area and we have this area. And we have 2x in red, which is the line. And we have y equals 1/2 x to the third in blue, which is the curve. Okay. So what we want to do is find the area of this part and add it to the area of this part. So we are going to, first of all, set the two equations equal to each other. So I'm going to multiply both sides by 2 to get rid of this fraction. So I've got 4x equals x to the third. And then I have 4x being subtracted from both sides. So I've got 0 equals x to the third minus 4x. Factor out an x. And we've got x squared minus 4. So x can be 0 You can't see what I'm doing. And x squared minus 4 can be 0. So add 4, x squared equals 4. Take a square root of both sides. Do not forget your plus minus. So x equals positive or negative 2. So I've got 3 points of intersection. I've got one at 0, which is going to be right here. I've got one at negative 2, which is right there. And I've got one at positive 2, which is right there. So this is going to be from negative 2 to 0, and this is going to be from 0 to 2. Okay, so on this side, what is your top curve? Your top curve is the 1/2 x to the third. So I have 1/2 x to the third minus, what's your bottom curve? Your bottom curve is the line. So it's minus 2x dx. Your other one flip-flops that. So the top part is the line. So I've got 2x minus the bottom part is the curve. So 1/2 x to the third dx. Okay, so we're going to take this one through. You have to give me a second to rewrite it. We're going negative 2 to 0 of 1/2 x to the third minus 2x. And we're going to add that to the other area, which is from 0 to 2 of the line minus the curve. Okay, so this one, when we integrate, we get 1/2 x to the third, x to the fourth over 4 minus 2x squared over 2. So when we evaluate at 0, the whole thing zeroes out. Minus 1/8, 1/2, 1/4 makes 1/8. Negative 2 to the fourth. My 2's reduce. And that gives me negative 2 squared. So negative 2 to the fourth is going to be 16. 16 divided by 8 is 2. Negative 2 squared is 4. So I end up with 0 minus negative 2, which is 2. So we're going to do the same thing, but to this side. So we're going to go from 2x becomes x squared, just like it did over here, minus 1/2 x to the third became 1/8 x to the fourth. And we're going to take that from 0 to 2. So 2 squared minus 1/8 2 to the fourth minus, it's going to zero out when we substitute in 0. So I get 4 minus 1/8 of 16. So I've got 4 minus 2, which gives me 2. And we're going to add those together, which gives me an area of 4. Okay? Okay, so the next set of equations that we have is y equals 1 over 6x. And y equals 1 over x squared. And x equals 10. So we're going to figure out where these two things intersect each other. If you want to graph them, which I strongly suggest you do, then go out on Google and type in Desmos graphing calculator, and you can enter in the equations and you can see what's going on. All right, so I've got 1 over 6x, and we're going to set that equal to 1 over x squared. What's your domain, by the way? I cannot use 0, otherwise I'll be dividing by 0, which is undefined. So I'm going to cross multiply. Subtract 6x from both sides. So that gives me x squared minus 6x is 0. Factor out an x. And I get x equals 0 and x minus 6 equals 0. If my factor is x minus 6, my solution is 6. So I'm going to go from 0 to 6. But I can't use the 0 because it's not in the domain. So this is where I'm just left with a 6. And wait a minute, I was given a 10. So we're going to go from 6 to 10. Of the top curve, which is the blue one, which you can't see what the blue one is, I just graphed it on Desmos. So I've got 1/6 x, or 1 over 6x, minus 1 over x squared dx. I'm going to rewrite this one. Actually, I'm going to use u substitution. So if u equals 6x, then du equals 6 dx. Solve for dx. Okay. All right. So just for this part right here, I've got 1/6, because here's my 1/6, that's my dx, of 1 over u. In the first place my brain goes when I see a fraction is the derivative of the bottom in the top? And it is, so my answer is going to be the natural log of the bottom. So I've got 1/6 times the natural log of u. And what's my u? My u is 6x. Minus, that's the same thing as x to the negative 2. So that becomes minus x to the negative 1 over negative 1 plus positive. And we're going to take that from 6 to 10. So we have 1/6 times the natural log of 60, which doesn't need to be in absolute values anymore because 60 is positive, plus 10 to the negative 1 minus 1/6. 6 times 6 is 36. I forgot my natural log. So I get 36 minus, which turns into a plus, 6 to the negative 1. And you can slap that in your calculator and go. All right, one more example. So we have y equals e to the x and y equals e to the 6x minus 1. Okay, and we're going to separate this with x equals 0. So same type of thing as last time. We're given a limit of integration. We got to find the other two. So we have e to the x equals e to the 6x minus 1. Since my bases are the same, I can ignore them. So I get x equals 6x minus 1. So I'm going to add 1 to both sides. And I'm going to subtract x from both sides. Divide both sides by 5. So I get x is 1/5. Okay, when you graph this on Desmos, you will end up seeing, what will you end up seeing? I'm looking here. Pause for one moment, please. You will end up seeing that the blue one is on top, which you can't see the blue. I'm looking at a graphing calculator again. So the blue one is e to the x. So I'm going to go from 0 to 1/5 of e to the x minus e to the 6x minus 1. The integral of e to the x is e to the x minus, I'm going to have to use u substitution here because I've got an inside whose derivative is not 1. So my u is 6x minus 1. My du is 6dx. So du over 6 equals dx. So I'm going to flip the, actually I'm going to go up here. I was going to say I was going to flip the page, but no, I will go up here instead. So I have e to the u, and then my dx becomes du over 6. And I'm integrating that. And so my integral is 1/6 e to the u. And that becomes 1/6 e to the u. Okay. So the integral of this becomes 1/6 e to the u. Well, my u is 6x minus 1. And we're going to take that from 0 to 1/5. So I've got e to the 1/5 minus 1/6 e to the 6th times 1/5 minus 1 minus, sub in a 0, and I get e to the 0 minus 1/6. E to the 0 minus 1 gives me -1. And that's your exact answer.